All right. Hello, everybody. Today's workshop, I'm going to be talking about deploying NFTs to the testnet. Hoping everybody's enjoying their DeFi summer hackathon so far. Starting up, I kind of want to talk about what a testnet really is. So, a testnet is a network meant for testing contracts and their functionalities on. Basically, a way for you to get up your smart contract somewhere without having to spend, real ethers on it. Some test nets for Ethereum include Ropsten, Rinkeby, Kovan, and Goerli. And to use a test net, you will need test ethers, which you'll generally be obtaining from a faucet, which we'll go over later. So starting up, I also want to bring up, why we use test nets, which is, well, as expected to test Ethereum software. You can also experiment with your software before mainnet launch. So say you just kind of want to see how it works at the moment, or how it interacts with your front end or anything else, or just show it to somebody else. You could deploy it on the testnet to see how that's working out. And you could also test how it interacts with other decentralized applications and other smart contracts that are also on the testnet, and make sure that everything's properly working with your Metamask wallet, which we'll go into later in a bit too. But next, I want to look at some of the testnets and kind of go over them a bit. So first up is Ropsten. The pros for Ropsten are that it best reproduces the Ethereum mainnet environment, since it's also proof of work. And because of this, it also has the largest chain data size. It's 15 gigs in total. And it has the fastest block time, actually, at 4 seconds, as opposed to the others, which all average around 15 seconds. Ropsten, you can use it with all clients. And because it's a proof of work chain, it's actually the only testnet that you can mine, as opposed to just obtaining it from a faucet. However, the cons for Ropsten is that it's not immune to spam attacks. In fact, in February of 2017, it was hit with a denial of service attack that made syncing so slow, and clients consume a lot of disk space. And it wasn't really back up until March of the same year. Next, I want to talk about the Kovan network. So the Kovan network is immune to spam attacks due to the fact that it's a proof of authority. It's also meant for use with the Open Ethereum client, actually. It does not support Geth. And after Kovan, we're going to move on to Rinkeby, which, just like Kovan, is a proof of authority blockchain. It's immune to spam attacks. Its supply is essentially controlled by a trusted source, which Rinkeby is the Ethereum team themselves. And Rinkeby is meant for the Geth client. So if you're going to be deploying with a test blockchain, you will be specifically using Geth with Rinkeby. And last but not least, we're going to talk about Goerli. Goerli is supported by multiple clients. So it's Geth and Open Ethereum are both on Goerli, as well as some others. It's also a proof of authority blockchain where the ethers are controlled and distributed by a trusted source. And Goerli is actually a testnet with the goal of being usable across all client implementations, and it's robust enough to guarantee consistent availability and high reliability. Essentially meaning it's the most stable out of all the testnets if you want to have like a stable source to test it on. While the most accurate one, as opposed to this, is Ropsten. Goerli also has the smallest chain data size at 0 gigs. Next, I want to talk about a few of the EVM frameworks. Or no, Faucets, I mean. So Faucets are websites that allow you to give an address that will dispense test ethers for use. Most Faucets, I know Ropsten's Faucet, you can actually use without having to do anything extra, but certain ones may have restrictions, like Kovan's requires you to have a GitHub account that you post along with your wallet address. And Rinkeby requires for you to make a social media post that you send along with your wallet address to them. And just for the sake of testing, I'll actually show Ropsten's Ethereum faucet, and I'm going to try and get some test ethers out of it, see if it does. I had just gotten some yesterday, so they might, IP block me from getting some for now. We'll see. Yeah, great listed. So you can only get some, I think, once or twice a day, depending on the amount of time between. But since I already got some yesterday, yeah, I'm graylisted at the moment. we're moving along. Now we talk about the EVM frameworks. So these EVM frameworks are what you're going to be using to like test your smart contracts, deploy them, run scripts on them, etc., and so on and so forth. Most are Node.js repositories with some exceptions. And starting up, I want to kind of discuss Truffle. Truffle is the most popular EVM framework. It's a part of the Truffle suite. It runs on JavaScript, and it's a Node.js repository. I'd recommend primarily sticking with Truffle just because if you're having difficulties with it, it's probably going to be the easiest one to get help with. And next up is Remix, which I think Remix is probably the most beginner-friendly one. It's got an interface for you to just write out your smart contracts, deploy them locally, and test them out, and even deploy them. But for large-scale testing and writing test cases, you're going to want to use one of these other frameworks. Remix is also in browser. It's an in-browser IDE, so remix.ethereum.org. You can go there and just look at what they already have. They have some default contracts for you to look at. The next framework to go over is Hardhat. So Hardhat is it's written in TypeScript actually, and because of this, it actually has more flexible scripting than Truffle. Like a Truffle normally requires you to write scripts specifically for deploying, migrating, testing, and so on and so forth. But with Hardhat, you can be a bit more flexible. And Hardhat also has support for plugins, and it comes with its own built-in blockchain. You don't have to use a blockchain client for Hardhat. Next up, I want to talk about Brownie. Brownie is written in Python, so if you're more used to using pip and using Python in general to work with stuff, Brownie's good. It's growing in popularity, and you can get a bit less cluttered of a work area than with JavaScript. And the last one I'm going to go into a bit of a detail with is Waffle. Waffle, kind of like Truffle, is built in JavaScript, but Waffle can also implement TypeScript. It's also compatible with TypeScript. And outside of those 5 there that I talked about, there's many more. There's like Etherline, which just went obsolete literally like 30 days ago, and DApp tools. But primarily just for this tutorial, we'll be working with Truffle. And next I want to talk about the client that we'll be using as well, which is Ganache. So Ganache is also a part of Truffle's Sweet Tools framework, or Sweet Tools, suite. And with Ganache, you can have your own locally deployed blockchain, with which is deployed on the local host server, as you can see here. I already have mine pulled up for what we're going to be doing today. Yeah, I'd recommend using Ganache just because compared to Geth and the others, it's probably the simplest one. Geth or Go Ethereum is another client that has its own blockchain, generally used for deploying. It's written in Go though. And also, we'll be using Infura, which Infura provides tools for deploying on Ethereum's blockchains and provides the API that we'll be using. It essentially provides instant access to the WebSockets for the Ethereum network. And here's the Infura setup that I have at the moment. And we will also be using Metamask. Now, Metamask is a cryptocurrency wallet browser extension that allows for interaction with decentralized applications on the blockchain. Essentially, it's the main tool you'll be using a lot for testing. There are others that are also used, like a Trust Wallet and Ledger Wallet have their cryptocurrency wallets that interface with smart contracts. But with Trust Wallet, right now it's mobile only. Metamask is also on mobile. And Nano Ledger, I mean, you have to have your Nano Ledger for that to even be an option. But yeah, we'll be working with Metamask in this tutorial. Here's Metamask's website that I've left in the resources section, and I'll probably post in the Discord as well later for anybody who wants to download and take a look at that.
And I think both Infura and MetaMask are made by consensus, so they might have a more kind of streamlined compatibility.
I think so, yeah. Just from working with it so far, because you have to go through a lot more of like a setup to work with Ganache and Infura, you have to download a whole other repository. But first, before I get to the NFT deployment itself, I want to talk about what's in an NFT. So when you mint an NFT, you have to pass it a token URI. And the token URI is essentially what contains the content of that NFT. Usually people will use JSONs like you see here that contain information like the name, the description, an image, the attributes, all this. And it's usually in an IPFS link, which what IPF is it's the Interplanetary File System, which is a protocol for storing and sharing data in a distributed file system. And but just for today, for the sake of simplicity, I'm just going to be minting this, which is the MPA logo, a link to the MPA logo. And with that all being out in the open, let's get into deploying the NFT itself. So this is the current setup that I have for everything. This is all just a basic truffle setup. It's only truffle, which to get everything here, you just type truffle init. Obviously not doing that here because I've already initialized the truffle project here. But it gives you contracts, which it only gives you one migrations. In the migrations folder, you only have initial migrations. You'll have to write the other migrations. This is just the node repositories. The scripts that I've written are here. It doesn't give you a scripts folder. You have to make that for writing your scripts. And it gives you a test folder, as well as a truffle config, which is where you'll be setting everything up. But starting up, I kind of just want to go through everything step by step. Starting with the contract that I have here, which is the contract we'll be using to mint and deploy the NFT contract itself. So starting off, the information that I found led me to use specifically this version of Solidity and specifically this version of OpenZeppelin. The OpenZeppelin / contracts part is a repository. I've left all the repositories in the GitHub that I set up that has everything here that you can use. Here in the constructor, we have the token counter, which essentially just holds which token ID the contract is on. This is the name of the NFT collection. And this is the symbol for the NFT collection. And here's function create collectible, which you give it the token URI and it just mints it to the sender of the message, which for the sake of this tutorial will be the owner. Then next up, I went ahead and I wrote to deploy NFT contracts, which is just this simple file here. All I really did was I took the migrations, which this requires all this to be built. So make sure before you do all this, you do truffle compile first. Make sure everything compiles. Oh no, wait, I had to set my freaking. So if you're using Windows PowerShell, you're gonna have to find this command. I'll probably copy and paste it somewhere just so you can see. But set execution policy, scope process, execution policy bypass. I have no clue why, but you have to do this before you can use truffle with Windows PowerShell if you're working with Windows. With that said, you can run truffle compile and it'll compile your this first compiles your contracts and everything, make sure it's up and running. It can be kind of slow sometimes, but yeah. So it's gotten the artifacts written to the build folder, which at first this folder will be blank until you build everything, in which case it's built all the OpenZeppelin contracts as well as the contracts given for it to build. And then there's migrations where it takes these builds and it just deploys them onto the blockchain, onto the given blockchain. So I'll go ahead and run that. Well, actually, no, we'll save that actually. We'll save it. But with that said, here's my deploy NFT script, which what this script does is it just gets all the accounts, which this requires the Web3 repository. I created the test URI variable, fetches the contract, displays the contract address, just to be sure, we had the right thing. Gets the owner account and make sure we have that. And here is just making the NFT, gets the counter value. prints it so we can see it, make sure that's correct, creates the collectible, given the test URI, and make sure it goes to the owner. Gets the owner value from the NFT itself to make sure it properly has that value, and gets the URI from the token itself to make sure it properly sets the URI. And if anything messes up in there, it catches and throws an error. So that's all this script is doing. Here's our truffle setup. So normally when you first get a truffle setup, you'll only be working with this network right here, which is the Ganache network. The port by default will be 8545. Just change it to 7545 if necessary when you initialize your own project. But I've also set up here the Ropsten network, so it calls to that. Here's my Infura key. I don't mind you guys seeing that. It doesn't really matter. And for the mnemonic, you will need to also pass in your MetaMask passphrase here, which, I mean, you guys can also see that there's no money on that particular MetaMask wallet. And here's where you pass it here in your HD wallet provider. The network ID is 3, which is Ropsten's network. And here's the gas. You may need to change this value sometimes, especially if deploying the mainnet, because if you don't give a contract or a transaction enough gas, it will fail. And this is the version of the compiler I'm running with. And now, with that being said, we're going to migrate this contract onto the Ropsten test network. So normally, if I just type truffle migrate, that should work, but that will only help with deploying it to the development network. We specifically want to deploy it to Ropsten's network, so for that, I would specifically put network Ropsten. And with that, we'll let it migrate. This might take a minute and be kind of slow with migrations sometimes.
Can you explain the difference between, so say you weren't on Ropsten and you're on mainnet, and you did truffle migrate, it would be on the developer network on the mainnet? Like, how is that different than main? Does it cost gas? Does it cost like real money, or is it
so
good?
Yeah, migrating to mainnet would cost real money. And it detected that I already
migrating to the developer on mainnet, or migrating to just mainnet?
Oh no, migrating development. So development is specifically just like, it's just my Ganache blockchain here. Like, that's specifically what development is. And it's reading that go ahead.
Yeah, I was just kind of asking the difference between the development. So the development is Ganesh, and then actually migrating it would go to the Ropsten, because you enumerated it.
Yeah, so like, I'm specifically calling this network right here when I do the -- network Ropsten. So for mainnet, you would have a mainnet set up here. Like, you have comma mainnet, and then you have all the mainnet information provided in there. So that's what the difference would be.
Okay, that makes sense. But the default migrates does whatever is under development.
Yeah, it just does development network by default. Which, just to show you what a migration would look like, since it's reading what I already deployed earlier. Truffle migrate. Compiles the contracts and then loads your migrations. Here it gives you your contract addresses and everything else that you need. Normally here should be able to get my hold on. Should be able to find my whatchamacallit, Ropsten address for this contract if I do this. Console network Ropsten. Polling tracker not found. Ropsten Infura.io.
I thought you just did it on development because you already put it on Ropsten.
Yeah, I just did it on development, but yeah, it's not really. I was gonna show like exactly where the NFT was on the Ropsten network, like using the Ropsten block finder, but it's acting finicky right now, so I can just show what happens when you execute the script and how it actually, like, it is properly logging all the information. This was deploy NFT.js. So it fetches the contract, displays the contract address, sets the owner account. Then here it says it's creating the NFT. Properly locks the counter value, properly misses the owner, retrieves the owner account from the NFT itself, and retrieves the proper URI from the NFT itself, which is, the exact thing I said we were going to put as a URI, the Minority Programmers Association logo.
So what if you so this a lot of times this URI is an IPFS address. But what happens when like that picture is no longer there? Like say the site goes down or hosted. Does the NFT still work?
From what I've seen so far, if the link goes down, you just kind of screwed over in terms of the NFT, which is why people prefer to use IPFS, since I believe it's more consistent in keeping stuff up, and if it goes down, it's the author itself taking it down, I believe. But yeah, normally I pull up the Block Explorer and show you where I specifically minted it, but
I mean, take the transaction ID so they can see that, because I want to see the actual URL. I want to see where we can see the URL. Where it says fetching NFT contract address. Yeah, try to copy that there.
Oh yeah, no, this is on the local. This is on the local block, so I had to specifically get it from like the Ropsten address, and it thinks that it knows I already deployed it to Ropsten earlier, so it's not letting me deploy it again.
Can you can you deploy one with like an incremented just so we can look at it? Or like
actually, yeah, I could do that. So for XX scripts deploy NFT.js network Ropsten. I believe that should work, unless it's reading the wrong Ropsten key or something. Oh yeah, there you go. And there's the NFT contract address again.
it's still going, right? There's still like more code. Yeah.
Yeah, there we go.
Now it should be.
And we put it in the Block Explorer, and yeah, here's our contract. We just created a collectible on it, and there's the info for the original collectible.
Wait, can you click that?
Yep, this is the NFT itself. Orders
contract on there. I'm gonna see the actual URI under
contract
holders, and then there's a tab that says contract.
Read contract, write contract. I'm not sure if you can view it on Block Explorer. I know if you have access to it itself, you could call token URI and it will return the URI to you. Yeah, it says 2 NFTs. The first one I made, the second one. Here's the second one. Yeah. Test NFT and state. But yeah, I'm not sure if you can view the actual NFT information on the Block Explorer, but like I said, you get the token URI value. You can call it there and it'll return the URI, the JSON or whatever you put on there itself for you. So there you go. This is the setup that you use regularly in deploying an NFT to the network. So with that being said, here are some of the resources. I'll be posting these later. Metamask, the wallet that I've used to interact with the blockchain, and Fura, which is the API provider for deploying onto the blockchain, testnet and mainnet. Truffle Suite, which is the framework that I use along with Ganache for writing and deploying, and the GitHub repository that I made specifically for this, which has just all these files, so you can take it and put all your information in and try it out yourself. Any questions?
Is this slideshow going to be available? Will there be a link in one of the channels?
I believe so. And if you want the resources, I'll post those. I'll be posting those myself afterwards.
And then also,
Thank you.
There's a GitHub called DefiSummer resources where most a lot of these things are being compiled and uploaded on GitHub as well. Yeah, but we'll be making that available. Yeah, but I'm gonna end the recording right now.